Hello students and friends, welcome to my YouTube channels. So now I am going to do the second support reactions problems. Here we are considering some point loads and some UDLs, two UDLs and 3 point loads I consider. So now I will solve this problem again one simple steps. So look how we'll solve. Already previous video I discussed, again that particular things we'll discuss and we'll solve. So already told whatever load will be there, UDL, UVL, point load. So everything will convert into single load like point load. So here no UVL, no uniformly varying load. Uniformly varying load means like this load will be there. This is also known as triangular load. But here what is given only? They given only UDL. This symbol will be like this or this symbol will be like this will be there. These are the same symbol. This is called UDL, this is called UVL, uniformly varying load, uniformly distributing load. So okay, so here they given only UDL. I taken this only. Next video when we will combine all three we'll do. That will be little complicated, but step by we'll explain this. Okay. So today we'll solve this question. Point load and UDL two load will be there. So, okay. So now very first work is already we discussed previous video. We'll draw the whatever load they given. We'll draw the another load diagram. All loads should be in point load only. So we'll extend this slowly, thin line will extend this. We'll extend this slowly and we'll draw the load diagram. We'll draw the load diagram. Now see another line I'll draw. So we've taken this line. So okay, now look here. We'll convert this given load into load diagram. So this is RA, support reaction. RA support reaction at point C. In between UDL is there. In between UDL is there. Where the UDL, already we discussed, again we discussed, previous video already we discussed, uniformly distributing load. That means per unit length. That means where will be the load. Suppose this load will convert into point load, that where that load will act. This load will act in the center of gravity point. Where the center of gravity point? Because already I told this is called rectangular load. So rectangle means center of gravity is middle point. Or another concept, if will be deflections, we will see now maximum deflections will be in middle. Why maximum deflections will be in middle? Because load will act in the center point. So that is what is this center point here? 2 meter. You will write here 2 meter, 2 meter. What is the load? Because this is given 6 kN per meter. See here 6 kilonewton per meter. If we will multiply into meter, what is coming? Load. So what is load unit? Kilonewton. That way also you can. So we'll write here 6 into 4, nothing but 24 kilonewton. 24 kilonewton. What is this one? Load. So we converted UDL into point load. Now next, already this is the point load is there. How much? 5 kilonewton, right? As it is 5 kilonewton. Next, what is this load? 6 kilonewton. 6 kilonewton I wrote. Now in between again UDL is there. In between again UDL is there. That is length is 10. Middle point will be 5. So draw this 3 meter, that is called middle point. Distance parallelly you write 2 meter, 2 meter, 3 meter. So now you look here that UDL, what is the length, what is the load? 10 into 6, nothing but 60 kilonewton. We got this load, 60 kilonewton we got the load. Okay, so we converted this UDL into point load. Next, any load is there? Yes, one more load is there. This load is known as load given 12 kilonewton. Then this is support reactions as usual RB. So we have to find out RA and RB. So now you forgot about this. This is the given problem. What we did? We converted we converted this into load diagram, point load. This is the new load diagram, and all I convert it into point load. Now see, very simple concept will solve. Two equilibrium equations will apply. This will check what type of load. This one simply supported beam, so only two reaction, three equilibrium forces. So this is called statically determinant force. Already we discussed statically determinant means if equilibrium equations will equal to the support reactions or less than the support is known as statically determinant. Indeterminate means support reactions will be more than 3. Then it's called statically indeterminate. So we know the equilibrium equation, sigma Fb equal to 0, sigma H equal to 0, sigma moment, total moment about any point equal to 0 is known as equilibrium equation. Support reactions only 2. So that means support reactions coming under the equilibrium equation. So that is called statically determinant beam. So we'll solve now. So we'll take here sigma Fb equal to 0, summation of total vertical force equal to 0. What is the concept I discussed before? Total upward force equal to total downward force. Very simple concept. No positive, no negative. Total upward force equal to total downward force. Total upward force Ra plus Rb, right? Ra plus Rb. Total upward force equal to total downward force. How much? 24 plus, because this UDL we converted into load, 24. This point load 5. All unit will be kilonewton only. Now 60 plus 60 kilonewton plus 6 kilonewton plus 12 kilonewton. It total how much it will come? That is called total upward force equal to total downward force. If you will calculate, it is coming 107 kilonewton. Give equations number 1. So total upward force, total downward force. Now next equilibrium equations, moment about A will take. Total moment about A, that means total clockwise is equal to total anti-clockwise moment. Total clockwise is equal to total anti-clockwise moment. So moment is equal to what is? Already we discussed before. Again I am telling, moment is equal to nothing but force into perpendicular distance. Force into perpendicular distance. So suppose an example I am giving here, one force is there, this point A, this point B. What is the moment? Suppose this is W, this is length is L. So moment about A, what is will come? A point is fixed. W, due to the W, this will rotate clockwise. So what is moment? WL. Load into perpendicular distance L. Load into perpendicular distance L. Rotation is clockwise. Okay, so this way we will find out here moment. Now look here, A point is fixed. This point is A, this point is B, then respective point is known as, you can give point are not required. A and B. So with respect to A, how this rotates? Now rotations will show the different color. So how this point is fixed, how this rotates? This rotates clockwise. What is this one? 24 into distance 2. Rotation is clockwise plus. Now here no load, 5 kilonewton. What is the distance? 3 plus 2, 5 plus 7. So 5 into 7. What is the rotation? Clockwise. What is the rotations here? Clockwise. Now next load is 60. What is the rotation? Clockwise. 60 into, what is the force? 60. What is the length? 336 plus 4, 10. This is also clockwise. Now 6 plus 6 into, what is the distance? 6 distance up to there. So 3, 3, 6, 9. 9 plus 4, 13. 9 plus 3, 13. So this also known as clockwise. Now another rotations, clockwise. All rotations is clockwise. See, this rotating clockwise, Now these rotations will be anti-clockwise, because this point fixed, RB pushing this beam is opposite direction. So equal to, clockwise is equal to anti-clockwise. So up to plus 12 will not rotate, no? Plus 12 into This distance is 4, this distance is 2. So 13 plus 4, 17 clockwise. So all load over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 equal to RB into total distance how much? Total distance how much? 19. What is? Total distance is 19. I am right? Yes. Total distance is 19. If we'll solve this, one step I'll write this calculations we did. 48 plus 35 plus 600 plus 78 78 okay, plus 204 equal to RB into 19. If we'll solve this, how much will come? 965 by 19. What is this one? RB there. So RB will come 965 divided by 19. It will come 50.79 kilonewton. Now this substitute RB in equation 1. Substitute RB in equation 1. So nothing but RA equal to 107 minus 50.79. It is coming finally 56.21. 56.21 kilonewton. Now we'll check once. Total is coming how much? 107 minus 50.79 equal to 56.21. So now look here. RA and RB. RA how much? 56.21 kilonewton. RB equal to 50.79 kilonewton. So this given load, how the RA and RB share? That is RA and RB known as known as support reactions. Support reactions. So we got this answer RA and RB we know. So this way we can calculate that. See the steps. If directly also you can do so many things we have to remember. So whatever the load they given, either UDL or UVL, will convert everything into point load. And point load simply force into perpendicular direction, moment force into perpendicular direction, and the load of total upward force equal to total downward force. Calculate and solve the support reactions. Where this application, once you will study the shear force and bending moment diagram, that time this part we have to solve. Then further we have to draw the shear force and bending moment diagram. That time problems will be completed. That we will study in the strength of material. This subject belongs to the engineering mechanics. So engineering mechanics only they are asking find the support reactions. Okay friends, watch the video and revise from beginning to end, and like this video and subscribe this channel. So okay students, thank you.